Welcome to the Real News Network. I'm Kim Brown in Baltimore. Scientists say that Arctic sea ice is declining at an unprecedented rate and may pose the greatest existential threat to the livability of the planet beyond all other drivers of climate change. Over the last 40 years, a team of scientists from the UK and the US have been measuring ice thickness in the Arctic from below using submarine sonar pointed upwards. And with us to discuss how extreme the condition of the Arctic sea ice is and the possible cataclysmic effects, as well as what can be done about it, is Dr. Peter Wadhams, who is an expeditionary Arctic researcher. He's also an emeritus professor of ocean physics at Cambridge University. He's also the author of a recent book titled A Farewell to Ice, a report from the Arctic. Dr. Wadhams, we appreciate you coming back to the Real News. Thanks for being here.
Pleasure to be here.
So you have been going under the Arctic sea ice pack for successive years over the past 4 decades. So what degree of thinning ice have you documented over that period? And talk about the acceleration of the recent decline.
Well, we started to detect a decline in the 1990s. And I first, in fact, I was really the first person to see a declining thickness because our submarines were reproducing more or less the same track each time they went. And so we were able to do some direct comparisons of thickness over a certain, quite a large area of the Arctic. And first of all, we found a 15% loss in thickness between 1976 and 1987. So that was the first evidence. But then later voyages, both by British subs and US subs, showed that 15% grew quite rapidly to 43%, and then it's got higher since then. It's about 50%. So the thinning has accelerated, and given now that the ice is only half as thick, this is in every season of the year, it's only half as thick as it was 30 or 40 years ago. And in summer, its area is only half as great as it was 30, 40 years ago. That means that the volume is only a quarter of what it used to be in summer. So that's 3/4 of the Arctic ice has disappeared.
According to the National Snow and Ice Data Center at the University of Colorado, as well as NASA and NOAA, sea ice in the Arctic and in the Antarctic set record low extents every day in December, continuing the pattern that began in November. So for the year 2016, sea ice extent in both polar regions was at levels well below what it is typical of the past several decades. So Dr. Wadhams, has the Antarctic also been affected to the same degree as the Arctic, and can we clearly tie warming of both regions to climate change?
Well, yes, the Antarctic has been affected now. And what used to be the case, or was the case until last year, was that while the Arctic ice was retreating very fast, the Antarctic ice was holding up, and in fact had been even making a slight advance. But this year, that is, 2016, that all reversed itself. The Antarctic ice has started to retreat quite rapidly, and while the Arctic ice continued its retreat, and in 2016, the ice area was a record low in really nearly every month of the year. It wasn't really. It's got worse this last couple of months as winter comes on and the ice has failed to advance properly. But it was also at a record low right the way through 2016, right from the autumn of 2015, when I was up there on an ice break at the Sikuliaq, and we found the ice in the Beaufort Sea failing to advance in autumn as it should be doing, and that failure led to a slower rate of advance right through the winter, so that every month of 2016 there was a lower area of ice than in any previous month, similar month, except for that just a little period in September, which is the absolute minimum time, when there was slightly more ice around this year, slightly more ice around than in 2012, which was the record holder. So we see right through this year, the ice had, except for this 1 month period with sea ice at an absolute minimum. And since September into autumn, when the ice should have been advancing, it's not been advancing properly in the Arctic, and also it's been retreating faster in the Antarctic. So you add the two together, and we now have got an unprecedented rate of loss of overall ice area in both polar regions. So it's now way below anything it's ever been before.
Peter, talk to us about the effect that less ice and snow coverage in the polar regions, particularly in the Arctic, has in terms of turning up the Earth's temperature even further.
Well, there's various global effects it has, and the first one, and perhaps the main one, is turning up the temperature faster, because as the ice area retreats, then the albedo of the Earth decreases. That is, you're replacing this white ice, which has reflects about maybe 80% of the radiation falling on it. You're replacing that by open water, which is dark and only reflects about 10% of the radiation falling on it. So you're changing the amount of energy reflected back out into space by the Earth by quite a large amount. You add to that the fact that we're also getting a big negative snow area anomaly in the Arctic, the northern hemisphere now, and add the two together, you're getting an albedo change for the planet, which is accelerating global warming. That's one big thing, and the most direct effect. But the indirect effects, which are also pretty serious and go in the wrong direction, are that the warmer air around the Arctic in summer months is moving over the Greenland ice cap and causing higher temperatures on the surface of the Greenland ice cap, and it's melting faster, and that meltwater is running down through the ice cap, causing glaciers around the edge of the ice cap to run faster and dump more icebergs into the ocean. So we're getting more mass of ice going into the ocean from the loss of ice from Greenland, which is accelerating the rate of global sea level rise, and that is very serious. Will give us probably much more than 1 meter of sea level rise by the end of this century, while previous estimates were something like 30 to 60 centimeters. So that's another big thing. And the third big thing, I guess, is the possibility that the warmer water now caused by the retreat of sea ice in summer, this allows water on the continental shelves to warm up, and that melts the offshore permafrost that there's been around the shallow waters of the continental shelf since the last ice age. That permafrost is melting, and what lies underneath is a large amount of methane in the form of methane hydrates. And when you go up to the Arctic in summer, you're now seeing very large plumes of methane coming off the seabed. If that were to accelerate some more, that would in itself also have an impact on global warming, would accelerate it.
Doctor, we're totally going to get into the Arctic methane cataclysmic potentially event that is awaiting us should ice continue to recede and melt. But I did want to ask you about the effect that melting Arctic sea ice has on weather patterns, and give us an example that we've seen in the last couple of years of how this melting of the ice at the polar regions is impacting Earth's weather in extreme ways.
Yes, well, what it seems to be doing, I mean, the connection is not as absolutely solidly proven as all these other factors, but it looks pretty persuasive, which is that because the Arctic is warming much faster than the rest of the Earth, is warming perhaps 3 times as fast, the temperature difference between the atmosphere in the Arctic and the atmosphere at lower latitudes is less. And the boundary between this Arctic air mass and the lower latitude air mass is this very rapidly flowing air current called the jet stream. Now, when the temperature difference was large, the jet stream was very strong, and of course it would blow you from America to Europe if you were flying that way. But as the temperature contrast decreases, the jet stream slows down. And so as it slows down, it goes into much larger lobes. Instead of being a sort of almost a straight line, it's gone into meanders. And these meanders mean that at certain longitudes, polar air can be transported down to low latitudes or mid latitudes, and at other longitudes, tropical air can be moved up to higher latitudes than it should reach. In other words, those lobes alternate hot air and cold air as you move around the planet at mid latitudes, and this is a very serious effect because it means in certain parts, I mean, typically, for instance, in the United States, you might have extreme cold in the northeastern states, while at the same time having extreme heat in the Midwest. It's just two different lobes of the jet stream. The result is very serious, is that these mid-latitudes are also the place where most of the world's food is grown. If you go right around the planet at mid-latitude, you find United States, Europe, the Ukraine, steppes of Russia. Those are big food-producing areas. And if you're going to give them weather extremes as we're getting, then that's going to affect food production, and which we can't really afford given our population is rising so fast.
Mm. Peter, another side effect of the rise in Arctic sea ice, rather the rise in sea level as a result of the Arctic ice melting, is a rise in the sea levels, which we are already witnessing with people having to relocate from shorelines, including recently in Louisiana, as well as an increase in storm surge that we saw during Superstorm Sandy affecting the New York City area. So there seems to be wildly different assessments from various scientific sources about how much of a sea rise we can expect, from 1 to 4 feet of sea level rise in the next century to 3 meters or 9 feet by 2050 to 2060. Now, you just said that you expect sea levels to rise about 1 meter by the end of the century. So what impact will that have on population centers around the world? Many of our cities are located on coastlines, and the people who reside in islands and other low-lying areas, as I mentioned, Louisiana, marshy places on the ocean fronts and that border those regions. What can these individuals expect going forward with 1 meter in sea level rise?
Well, I said a meter. It was really to simply to say that the rise during this century is going to be more than the official figures coming out of the Intergovernmental Panel on Climate Change, which are still lower. They had got some very low figures out, but in their last assessment, they went up to 60 to 90 centimeters. So officially, we're still not at a meter by the end of the century. But as far as any glaciologists are concerned, or all glaciologists are concerned who've looked at the rate of melt of the Greenland ice sheet and the way that's accelerating, we all expect more than a meter, and by more, it may be much more than a meter. People like James Hansen, who's very well respected, can put forward good reasons why he thinks it will be 4 meters. That's still a kind of outlier. But the more you look at what's happening to Greenland ice sheet, the breakup of the ice, the way in which the melt is enhanced by the melt water flowing down through the ice sheet, and then the fact that these processes are starting in Antarctica as well, then I think that 1 meter is going to, as a kind of conservative estimate, is going to keep going up. So I really don't think it's going to stop at a meter. But even if it were just a meter, that's still pretty disastrous. It doesn't sound that bad, because you would think, well, all we have to do is raise our flood defences by a meter and we're okay. But what that means is we have to raise our entire coastlines by a meter, because the world water has a way of finding its own level. And that means that we we can protect wealthy parts of the world, but we can't protect the poor parts of the world. So we can protect the coast of Netherlands or even the coast of Britain, but we can't protect the coast of Bangladesh or the coast of eastern China, where you have a very large amount of low-lying land with huge numbers of farmers, poor people living right down at sea level in an area with lots and lots of inlets like the Bay of Bengal, and a high population living beside the sea and then a high population behind them. So poor farmers in Bangladesh living right down at sea level, if there's a flood or storm surge, they can't move anywhere. They can't move back to high ground because the high ground is occupied by another few million poor farmers. So they just have to stay and drown. And so there is going to be more and more frequent storm surge disasters along exposed coastlines of poorer countries that can't afford flood defences. And you increase the mean by a metre, then you increase the frequency of serious floods by a very large factor. It's not a linear process. You think a metre is not very much, but when you look at probabilities of storm surges or intervals between storm surges, those probabilities go up very rapidly when you change the mean. So it's bad news for poor countries, and even when we move to richer countries, we are getting to a point where you can't afford to maintain or raise flood defences along the whole of a coastline. I mean, the US case that's most vulnerable is Miami, because there you're getting the water coming up from below as well as coming in from the side because of being built on porous limestone. So the effects are very much worse. And so there, a sea level rise of a metre could well cause the city to have to be abandoned. And the impact on the national economy would be very high. I mean, not least because of the way in which real estate prices and values are such a large component of the overall national economy because of coastal real estate being very, very expensive. So I would think we'd have to look very much at what individual cities have to look at how they're going to respond to the fact that the sea level rise that's going to happen is greater than they've been led to expect. They have to try to make plans, and not all cities can make plans for that. So certain cities will have to think about moving.
Well, Peter, I understand that there has been some dispute over how soon we might see an iceless Arctic in the summer. So how soon could this happen based on your observations and data, and what might the effect be if we see no ice in the Arctic during the summer months?
Well, I think it could happen next summer. I mean, I know I'm accused of constantly saying this, but in fact, in this case, it's really looking as if it may well be that, because primarily because the growth during this winter has been much less than it normally is. So we're going to end up with a winter maximum which is much lower in area than we've ever had before. And that winter maximum is made up of first year ice, which is thin. So there's every possibility that this coming summer, this September, will be the first summer without ice. Now, it in itself, it doesn't make more of a difference than simply a retreat, because the retreat that's happened up to now has already exposed the continental shelves of the Arctic to being open water in summer, which is what's allowed those coastal waters to warm up and give us this methane threat. So that's already happened, because already the only ice that's left in summer is in the deeper central part of the Arctic Ocean. So the loss of that would be mainly an albedo effect now, that the methane effect is already taking hold. So the further loss to leave us with no ice at all would be primarily the immediate effect would be on the Earth's albedo, but also it would mean the Earth has completely lost its air conditioning system in the summer, and that will delay the subsequent freeze up in the autumn, because there'll be so much water heat being put into the ocean by the solar radiation in summer that it will slow down the subsequent winter growth rate even more, and we'll have something next winter worse than we've got this winter. What we're getting this winter is limited growth of the ice. So next winter will be even more limited growth. So in other words, we're going to get to the point where we're not getting the ice back properly during the winter. So what may well happen is that the winter growth rate will give us a much more rapid loss of winter ice area than was previously expected, as well as the summer ice disappearing completely.
We've been speaking with expeditionary Arctic researcher Dr. Peter Wadhams. He's also an emeritus professor of ocean physics at Cambridge University and the author of the recent book titled A Farewell to Ice, a report from the Arctic. So please join us for the second part of this interview on what has been called the Arctic methane emergency, considered one of the greatest possible threats to our existence. And we'll ask Dr. Wadhams if it can be stopped. Thank you for watching the Real News Network.